Hello, my name is Dumba Jonah from Group 29, and I'm going to explain reinforced deep Q knowledge distillation for bovine respiratory disease detection with multi-strategy learning. And so far, the product that we are selling, it's an AI livestock care, and we are dealing first of all with one disease, bovine respiratory disease. Why this disease is also called the shipping fever. It is a severe respiratory illness or disease in cattle that leads to significant economic losses in the livestock industry. Why is it even a major concern? Basically, it leads to late diagnosis results, and with these poor results or late results, it can lead to the poor treatment and also the high economic burden due to the veterinary like costs and cattle losses. When this disease breaks out late or like in the late stages, it can lead to high costs, also cattle losses when they die. And lastly, inconsistent manual detection by farmers and veterinarians. It can be costly and also tiresome. Therefore, with this approach, it can be the burden can be taken away. So the project objectives we want to develop, basically we developed an AI-driven approach for the early detection of the bovine respiratory disease. Also to improve the detection efficiency using reinforcement learning as well as knowledge distillation. And also we want to provide an accessible and scalable solution to cattle farmers. So this solution, we introduced a reinforced deep Q knowledge distillation approach so that it can improve the detection of the bovine respiratory disease. So we did this by combining the reinforcement deep learning and deep learning, as well as using knowledge distillation for the efficiency of this approach, and also multi-strategy learning for better generalism. So the data we used, basically we emphasized on the sensory data. Basically we want to bring the approach of cattle having each cattle having a collar, and each collar having sensors to monitor the cattle, the movements, line bouts, and also the temperature and many other data. So basically the combination of public and custom collected data is what we want to use, and among the sources we want to use the clinical records, behavioral patterns, feeding and milk intake data, environmental factors, and many others. Among the pre-processing, we want to the pre-processings that we have, the missing value imputations, feature scaling and normalization, and as well as label encoding for categorical features. Model techniques, basically the algorithm is using a deep network, knowledge distillation, and also dense neural networks. Why these models? The DQN or the dense neural network enhances, deep Q network enhances decision making for early detection of the bovine respiratory disease. Also, knowledge distillation, which ensures the efficiency of the deployment on the edge devices, or like the devices the users that will be using. And lastly, the deep learning models to capture the complex patterns in the health data of the cattle. And the system architecture, we have it has the input, pre-processing of the data, like the feature extraction and also the transformation. Also the model training according to the model that we have, and the prediction output. The model will be able to tell us is the cattle at risk or not. If it is at risk, it will alert the farmer in real time. Then the implementation details, basically we're using the Python language, libraries and frameworks. We're using the TensorFlow and stable baselines 3, also the skitlearn. And the platforms that we are using Google Colab and also the cloud. We're using Render for now. And the results and evaluation, basically our model, the accuracy and precisions are high in this detection, approximately 90 and above the percentage, and it's highly effective. And among the competitive analysis, we have these competitors, and their product and strength and weaknesses that they have. And among all those, the opportunity that we focused, we sought out, we want to provide a fast and on-site AI-powered prediction for the bovine respiratory disease and with real-time data collection. Also to focus on early detection of BRD, helping farmers act before treatment becomes necessary. Also to enhance prediction capability with AI-driven BRD detection based on real-time data. And lastly, to create a more specific, faster solution for the BRD detection. And also, why is this approach impactful and also relevant? We want to be able to support local farmers in Uganda in minimizing the cattle losses, and then further, I want to go even beyond Uganda. Also to reduce reliance on expensive veterinary diagnostics. So, and what are the sustainable development goals in this approach? So we want to improve the health of the livestock, and also the good health and well-being, so that we can prevent more outbreaks of the disease. And the scaling and monetization, basically we want to be able to earn money from or like capital from the subscription based on the software as a service for the veterinary clinics and farmers. And also for those that are in far places like the rural areas, we want to be able to give them the on-device AI model deployment for the offline version. Also, the market size and potential. We are targeting basically the cattle farms in Uganda and expanding globally. The potential adoption in dairy and beef industry worldwide. So our request for the funds, basically that's the amount, and to get a lot, for example, like the cloud deployment and market expansion. And we are looking for partners in different sectors like the veterinary institutions, agri-tech farms, and research bodies, and many others. And why should this approach be invested in? Basically, there is a high growth market since this approach is not that common, it is still new. Also, the scalable AI technology and strong industry demand for this on farms. And the intellectual property and innovation, the patent and copyright and trademark, and as well as the trade secret of this product. We want to be able to protect it as ours. And this is the proposed budget. It encompasses the small scale project, mid-range project, as well as the large scale project. So it shows the we have the low estimate and the high estimate. And according to the system demonstration, the video is there. And I'll just give you a short preview, just a short wind up of this UI. Basically, it has where you enter in the data set specifically that you want, and it gives you the options here according to how the data set is. So far, according to how the data set that we used, it asks us these details, and after entering these details or a sample, then it predicts according to those samples. Should a farmer intervene and go check that cattle for take it for treatment or not? Also, this is the contributions and among the team members. My name is Dumba Jona, and I did the model development, AI pipelining, reinforcement learning integration. Nawanga Afua, my colleague, worked on the data collection, pre-processing, and evaluation. Among the challenges we face are those ones. Working with unbalanced data, optimizing model efficiency, and through those challenges, we learned a lot, the importance of explainability in AI, also balancing the model accuracy. So among what we have covered so far, the model development and validation, cloud deployment, but we want to commercialize this approach on a large scale and also expand the livestock disease detection to other diseases and globally. So So that's it for now. Thank you.